Welcome to this video on frequency table and histograms. By the end of this video, you should be able to make a frequency table, create a histogram, and read and interpret histograms. So a frequency table helps us group data values into intervals, and then the frequency is the number of values that are in each intervals, and then we can use that to actually make a histogram. So here's what we're going to do. We have some intervals that are made. And so I'm going to look at each number. 81 would go into this interval. And I'm just going to make some tally marks for each one. 55 goes in this interval. 100 goes here. 94, 61, 80, 77, 74, 92, 95, 52, 86, 90, 78, 81, 100. Now this is going to be the fifth mark, so I'm just going to do it across like that. So when I see one with cross, I know that's 5 already. 65, 81, 70, and then 94. So I know 2 people got between a 51 and a 60 on their math test. 3, 61 to 70. 4, 71 to 80. 5, 81 to 90. And 6 people had between a 91 and a 100. So it just helps me kind of put the data so it's a little easier to see it, group it down for me. So pause the video and go ahead and make your frequency table for the second set of data. All right, for the second data set, I got 7 completed 7 laps around the track, 10 between 6 or 10. I got 6 between 11 and 15 laps, and then only 3 made it 16 or 20 laps. Now we're going to use these data values to create a histogram down here. So the height of the bar will tell you the frequency, or how many, we'll say the number for that data. So we're going to, for 1 to 5, laps 1 to 5, there were 7. So I'm going to go as high as 7, which is right here, and I'm going to have it come down right on that spot. This is called a bin. All of these numbers were thrown into the bin. You can't see the individual numbers, you just know there's 7 of them in there because how tall the bar is. Our next bin will have 10, so that goes all the way up to the top. And then I'll complete it. So I can't see the individual numbers inside the bin, but I know there's 10 numbers in here. Then our next one is 6 high. And the last one is 3 high. So that's how we're going to make our histogram. Most often, you're not going to have to make a histogram. You're just going to have to be able to answer some questions about it. So let's take a look about reading this histogram. So how many runners are there? So if you're not given the individual data points, you're going to need to count. There are 7 here, 10 here, 6 here, and 3 here. So you're going to have to add them all up. 7 plus 10 is 17, plus 6 is 23, plus 3 more is 26. So we had a total of 26 runners. Okay, how many runners ran a maximum of 15 laps? That means less than 15. So we're talking about here and that way. So we just need to add up that group. 10 and 7 is 17, plus 6 more is 23. Okay, how many runners ran at least 6 laps? At least is greater than or equal to, so 6 laps or more. So you want to add these 3 groups up. 10 and 6 is 16, plus 3 more is 19. And then which interval contains the least runners? So this is the smallest one, so that would be the 16 to 20 laps. All right, let's try answering some other questions about histograms. Okay, so here we have a histogram on the birth weights of students in a class. So when I'm looking, I see that there's 1 person in this group, there are 3 people in this one, 9 people in this group, 6 and 1 in this group. So these are their birth weights, 5 to 5.9 pounds, 6 to 6.9 pounds, and so on. So you can see their weights down here. How many students weighed between 7 and 7.9 pounds? So we're talking about this interval here, and there's 9. So 9 students. How many students weigh less than 8 pounds? So here's 8 pounds, and I want to know less than. So I need to add these 3 groups up. So 9 plus 1 is 10, plus 3 more is 13. So there were 13 students that weighed less than 8 pounds at birth. And then which interval contained the most students? Well, that's going to be your tallest one. And so that's going to be the 7 to 7.9 pounds. All right, our next question asks a little differently. It doesn't want to know the number. It wants to know the percent. Okay, so here we have the typing speeds of students in a keyboarding class. What percent of students type between 41 and 45 words per minute? So they're talking about this bin right here. So how tall is that? That is 9 tall. But it's 9 out of the total. So I know the 9. I need to divide it by the total to help me get to my percentage. So I need to know how many people are in the class. So there are 3 here, 9. This is going to be 5. This one will be 2. And that one will be 1. So we're going to add them up. 9 plus 1 is 10. Plus 5 is 15. Plus 2 is 17, plus 3 more is 20. So there's a total of 20 students in the class. 9 of them fall into this bin. So when we divide 9 divided by 20, you get 0.45, which you multiply by 100 to turn it into a percent, which gives us 45%. All right, we're going to try a percent question again. So our next problem, number 6, the histogram below shows the test scores on a science test by a group of students. What percent of students scored between 91 and 100? So they want to know about this bin right here. Okay, in that bin, there are 24 people. So we know it's 24 out of some total. So we need to know the whole total. How many people took the test? So this bin has 30 because it goes up to the 30 line. This bin is halfway between 18 and 24, which is a distance of 6. So that's a 3 more, which makes that 21. 12 people are here. 6 people are here. And this last one, here's 6. This is half of the 6. So that's 3 people in that bin. So when we add these all up, I'm going to use my calculator. 3 plus 6 plus 12 plus 21 plus 30 plus 24 gave us a total of 96 students took this test. 24 of them scored between 91 and 100. I want to know the percent, so use your calculator. 24 divided by 96 should give you 0.25. You times that by 100 to turn it into a percent, and we get 25%. All right, one more, determining some percentages. Here's our last example. The histogram below shows the number of raffle tickets sold by a group of students. What percent of the students sold at most 15 tickets? At most means less than or equal to. Okay, so 15, this is 11 to 15, so they're talking about 15 or less. They want to know those 3. And it's not just those 3. I don't want to know the number. I want to know the percent. So I need those 3 divided by the total number. So let's see. It looks like we're counting by 2's here. So this is a 2. 20. Halfway between 12 and 16 is 14. Then we have 6. And then we have 8. When I add these up, there's 22, 36, 42, 50. So we had a total of 50 students, or 50 people who bought raffle tickets, and then 20, 34, 35, 36 of them sold 15 or less. So 36 out of the 50. Divide top divided by bottom, and you get 0.72. times 100 to make it into a percent gives you 70% of the tickets sold by a group of students was at most 15 tickets. Right? So hopefully that was helpful to help you answer the practice questions, and I'll see you in class.